All right, we are live for class 7. I'm sure some people will trickle in here, but welcome to the last week of SQL 101. Right. Yeah, it's been fun. I enjoy this. It's been fun watching going from the first week, just getting everybody connected to everyone doing pretty well, slicing through their homework and getting the material. I'm going to give it a couple more minutes here because when I switch to go through the deck, I won't be able to see people coming in. All right, I'm just going to go ahead and get going. All right. Today we're going to go over storing and managing enterprise data. This is going to be the last class with the lecture. Studio is full. Well, not sure what I can do about that. All right. Yeah, and then what I'm going to do is I'm going to hand out the final today. That's due before class, the next class. And then what we're going to do on Wednesday, it'll be a working session where you get somebody's final and I'll give you the answer key and you grade it. So, mark it correct, incorrect. If they got it incorrect, then, what I want you to do is in plain English, maybe give them a suggestion or supply some code, to help them out. Give me a second here. It's asking if, it's just saying people are trying to get in, but I need to upgrade. Give me a second. Let me text Nate here. Okay, I'm texting Nate right now to see what's going on with the link. All right, right, so Nate's working on getting that fixed. Just give me a second here. Sorry about that, guys. Let's yeah, there's some people trying to get in here. We'll see if Nate can resolve this. If he can't do it, then we'll just move forward. All right, let me all right, he's working on it. I'm gonna go ahead and just move forward, and then I'll let them in as soon as he's done. They won't miss much. Okay, so today we're gonna take a look at the enterprise level view, looking at ETL strategies, how they store data, how do they manage it, what's the difference between data management and like a database administrator. Talk about data governance, stewardship, data quality. We'll take a look at data dictionary, ETL, ELT pipelines, that sort of thing. So not much programming today. I don't think we're actually going to look at any programming today. This is going to be more of a kind of a high level strategy session. So last week we went over OLTP, OLAP, different ways to structure and store data. Went over some modeling techniques. We did some ERDs, relational database modeling. Took a look at normal forms. And yeah, I mean, it's, you know, and this class is, I think, going to help you visualize that stuff more. I did get a lot of questions about the diagram and how to draw that stuff out. Okay, let's see if they can get in now. It's not working again. Okay, so I'm gonna proceed forward. I can't bring anybody else onto this, and then when we're done with the lecture, I'll restart it. If you want to hop on, if you're gonna have questions or want to discuss something, feel free to hop back on. Okay, so we want to understand a bit more about data storage terminology, organizing, organizational data flows, like we mentioned before, management versus admin. How do we approach measuring data quality? And then a really handy tool, data dictionaries. So, the three main types of enterprise data is going to be transactional, like we discussed before. Think of that as if you've got a CRM or something, and maybe that's connected to all of your sales. All of your sales data is going to be your transactional data. Your analytical data may not use all of the sales transactional data, but will pull what is relevant for you to perform analysis on business performance. And then your master data is holding information about key business entities. So for example, like we would say, like a fact table would be your transactional data, and your dimensional table could be a portion of your master data. An example of with that would be like you've got a transaction of all your sales, and then you've got a customer ID, and then master data would be your customer ID, and then all of the data that corresponds back to that customer. Maybe it's, where they're located, any demographic information, their address, their phone number, that sort of thing. So, data storage terminology, I'm sure I've confused all of you at one point and another using different terms. That's because it's pretty common. How fast things are changing. There used to be data lake, and then separate from that was data warehouse. Now there's data lakehouse. You've got data pipelines versus, if you're just talking about like a ETL process. So it's pretty common. You'll hear different language for different things, but it kind of depends on like the technology that you're working with. So we discussed OLTP, which is focusing on transactional processing. So I gave you one example of the CRM, ERP system, e-commerce. You've got like, let's say a legacy system. That could be something like you've got an old software system that you've sunset, but you still need to get relevant old data out of that system. External, that could be like you need to pull in Google Analytics from all of your different websites. Could be like, let's say if you're using a third-party vendor for like customer satisfaction surveys. Could be a multitude of things. Another one might be like your payroll software. And so as we move from like our data sources and we're going through the enterprise data warehouse, your online analytical processing is going to be stages over here. So after you've exported, transformed, and loaded, you could do an operational data store, a data warehouse. And the next slide, we're going to look at maybe a different way to store it, but it's all got some sort of flavor of this. And what's very common now is that data teams are creating data marts that are, I guess, kind of like democratized for different teams. So like maybe finance has its own data mart with only data that's relevant to what they're going to be looking at. Maybe human resources is a different one. Maybe sales is a different one. And then what you're using to create those is your OLAP models. And then you're going to load those data marts into, BI tools going to be like Tableau or Power BI. Also, same thing, reports and dashboards, but your reports could be, oftentimes, you may just create like a Excel file. Maybe it's like just some columns and rows. Like that's a work queue for somebody to go through. If they've got let's say they're trying to collect payments for accounts receivable, maybe you produce an automated list for them every morning for accounts that they need to call on. There are some times where data teams are working on creating a data product. It's not something we really have gone over, but what that is let's say you're creating a product from your data and the data is generating revenue. So the best example that I've seen this when the last employer I was at, we ended up selling to BlackRock, and they put me in touch with a sister company called Transactional Data Systems. And what they do is they develop custom software for independent pharmacies. So not CVS, not Walgreens, and not hospital systems. And they were doing about 70 million in revenue a year. About 30 million to 40 million of that was some data products they built. And so what they were doing is taking the self-pay data out of pharmacies, so people that don't have insurance, and then they were selling that back to the pharmaceutical manufacturers. Why would pharmaceutical manufacturers want that? And why can't they get it? So if it's an independent pharmacy, and there's no claim attached, right? If there's an insurance carrier, they could get it 1,000 different places, but there's not. So the only place that lives is in that pharmacy's database. And so what pharmaceutical manufacturers would want to do is maybe they need to work on distribution channels. Where do they think they need to be, sending more medication into what pharmacies? Another example, which kind of surprised me, is commission. So pharmaceutical reps, they get commission, right? And they would use those reports to then generate commission for their pharmaceutical reps. Of course, it's got to be a pretty high value to make anything that's relevant. But that's just one example. Okay, so how does data flow? We've got various data sources here, whether it's enterprise applications, OLT databases, third party, just like we saw here in the previous slide. And we could do one of two things. I mean, we can pull that stuff and stage it into a data warehouse. The better method, though, is if we took everything and we stored that into a data lake first. That's essentially just saying, like, I'm going to go grab all this data. I'm going to throw it into a data lake, but I'm not transforming anything yet. And from that data lake, then you could do your ELT or ETL process to create the data warehouse. So people go both ways. This is a common image I found. My personal preference is actually just staging everything in a data lake and then pulling it into a data warehouse later on, which is going to be your OLAP, your OLTP. Data lakes are mostly going to be that. I don't know if this is going to work here. Yeah, I can't add them. All right. Okay, so ETL versus ELT. Anybody remember the difference? What that is? So there's export, transform, and load versus export, load, and transform. So exporting the data, you're just taking data from different sources, pulling into a centralized staging area, transforming the stage, you're manipulating it, you're cleaning it, you're normalizing it, you're making it in a uniform format. Maybe you're creating some keys so you can tie things together. Like, what's your payroll per sale? And so you've got an automated procedure that's going to extract data out of your sales software. I don't know, maybe say it's Square. And then you got a procedure that's going to pull out of your HR software. Maybe it's ADP. And then you're going to create a key that, ties those locations together. So maybe it's some location ID or something like that. And then your loading stage is where your final target's going to be. That could be a data mart. It could be, a data store. It could be an OLAP set of database tables that you're then feeding into Power BI. And essentially, the loading stage is whatever you're going to use to create analytics. And let's not forget data science, right? Machine learning and things like that. Typically, you're going to have a separate OLAP database for that just because it's so different. So there's typically another stage of transforming in there. So what's the difference between data management and DBA? So data management, other word stewardship, is organizing, maintaining data processes to meet the life cycle needs. It doesn't need to be a person or a single person, I should say. Typically, like these days, I see a lot of chatter about having different process teams. So like if you're HR one, ops one, sales one, kind of federating the way to manage the data. So for example, like maybe somebody from HR loads another location or team into the software. They're going to let you know about it, and they're going to tell you how to map the data accordingly. Or another example is, let's say you're selling a bunch of items and those items have categories. Your product person is going to reach out to you and say, hey, I've loaded this system. When you pull it, I want it categorized this way. Doing that centrally doesn't make a whole lot of sense because processes get big, the details become immense, and you want somebody who knows their process to really help you out in that regard. So a database administrator is going to be your technical person, specialized in the software to store it, organize the data, planning, installation, configuration. How do they design it? How do they migrate legacy systems, into the current environment? They're going to monitor the performance, control security. They're going to take care of your backup procedures, your recovery, make sure it's geo-balanced. So always having some recovery methodology into place. There are similarities between the roles. Think of your database administrator as like your physical technology administrator. Data administration is going to be your more logical. And how, all these come together for you to be able to create a successful data model and then manage your data. You don't need to think of it as a person, data modeler or data manager. I mean, oftentimes data teams are fairly new to the party. And so, one person comes in maybe at a senior level or maybe not. And there's an attempt to wear multiple hats and then until they eventually expand. So what's data governance? These are going to be like your rules, your quality control, your disciplines for assessing like how everything is performing. It could be, let's say monitoring database changes. Let's say you're on an accrual-based accounting system and you're, shipping items, generating invoices, and you've got accounts receivable. And so revenue is supposed to be posted in an accrual accounting way, meaning every time something goes out the door, like that's what revenue is supposed to be, or whenever you've generated that charge. And somebody's going in there and let's say they've shipped something else at a previous date and they get a payment and they post it to the wrong sales date or something like that. And you're monitoring changes over time because it's like backdating the system. Or like, let's say, somebody returned a product and instead of doing a return transaction, they go in and delete the charge. So, and it was a big order, right? So for whatever reason, you checked revenue from last month, it should be the same, but they've deleted that charge. So now you're out $50,000 in revenue and you're off. So what accounting is going to do is they're going to immediately come to you and say, what happened? Why are we, why is revenue, is it understated? Is it overstated? What happened? Let's say you all of a sudden have a spike in some particular product category. It's showing that, historically, all of a sudden it jumped up $1 million. Maybe somebody went into the system and they recoded all of, these transactions at a particular category that changed historical data. So these are really important things that you've got to be aware of and govern to make sure that the organization stays accurate and the business rules are being followed. Stewardship is, how do we enforce those guidelines? How do we identify those guidelines first and foremost, right? Usually you come up with what you think is best, and over time you see a bunch of stuff you could have never imagined occur within a system. And then you have to come up with rules, on the fly and then fix whatever happened. This is definitely more advanced, but ways that I do that is I'll create programs that monitor that. So like we said before, let's say we've got, somebody had a returned item and then they went back and just deleted the charge instead of showing the offset of returning that item. Is I'll pull all the numbers, let's say LTM of sales or revenue. I'll capture that and then I'll run everything again and then I'll see if anything changed. And if something changed, I'm going to get an email that's producing a specific error alert and where for me to look, like what location did it occur at? Who's the user that did it? That sort of thing. You can also, another common error that I see is in the data entry process, somebody starts, they create a new category, whether they're lazy or just didn't see it or they're new or whatever. And so now I've got I've got duplicate categories that are in my dimension table. And so when I've now joined that in my OLAP models, I'm getting duplicates all over the place. So maybe I've got something that's monitoring the dimension tables to see if there's been any new additions, or I'm monitoring any duplications or any errors. So let's say a program doesn't run, as oftentimes you're running a bunch of objects that are dependent on one another in the transformation process. Something doesn't run. So if there's an error, I'll have a log file that then is going to get emailed to me, or a summary of what's in the log file telling me the error and what file it was so I can go look at it. So if you can imagine, I mean, it becomes a pretty big operation quickly. I'd say where most organizations, they run analog or some shape of, I've got multiple business units and I'm just using canned reports. Once they get to more business units and they have fingers on one hand, it goes downhill pretty fast, and then they usually look at investing in some professional or team to help them manage their data. So data quality could be errors, could be incorrect elements. Jonathan got here early, and I was talking to him a bit about a frustration I was having today, where very basic fields like the number that is tracking the transactions for charges, it's just gone for like $50,000 worth of charges, which I didn't even know the system can do, and it's pretty sporadic. So what is that? I mean, I can't tell you by looking at the data. That's where I have to collaborate with the operational team to try to figure out what that is. And then, something like $50,000, depending on the size of the business, could be material or immaterial to an accounting team. And this particular instance is a small business. So, that's something that sitting in front of an auditor on an annual basis is going to come through and say, hey, what's going on with this? And you've got to be able to get back to them with some sort of response. So you can develop quality assessments, making sure things are consistent, like looking at historical, if you're going to refresh the data, look what's there from the last refresh compared to what's there on the new refresh. Uniqueness, making sure that it's void of duplicate records across your joins. Timeliness. So let's say if the expectation in an automated ETL process that's got dependent objects. So you've got, a couple objects are extracting data. You've got some objects that are transforming data and staging the data. Let's say one of them is taking longer than usual to run, and then it doesn't get picked up in that dependency. So it's good to make logs of when things are being completed that you can check on. The validity of it. Is there any wacky errors going on? If you know that your product amounts are between $100,000 and $10,000 and something's 1 million, and for some reason this keeps occurring, you create some sort of logic that searches the data and says, pull me any records that are producing a charge over 10,000 because it doesn't make any sense. And then you can go back and see who put it in. You can train them. Not every system is perfect. That's why this stuff is so important. It's not academic at all. Like you've got to enter data in for everything, right? And sometimes systems will allow you to enter things that are undesired. Like somebody start entering, let's say pound signs into somebody's name. It doesn't make any sense, right? But if you didn't account for that pound sign and for some reason maybe it throws off some of your programs, you've got to go fix it. You can also, a lot of organizations that I've been with, or once they get mature enough, doesn't always apply to small businesses, you get evaluated on your performance metrics, right? And so do data teams. And, typically we get measured on, let's say adoption. So, how many people that we want to see our reports and dashboards are actually looking at those. Another one is going to be data quality. You can think of it as like uptime for IT. That's the big measurement in the IT infrastructure world is I'm paying for four nines of uptime or whatever it is. I mean, you could make something like that for data quality. Over the course of a month, we did not meet our update time by, 3 days. And we had like 4 quality report issues. And, so we were, let's say we were 98% uptime within our system. So data quality using Python, that is typically where I do a lot of my work. And I know a lot of you are taking the Python class. So here is a resource that can get you started on that. But yeah, you can do all these things in Python. I mean, you can look at your data in Python. You can then perform calculations, produce log files from Python errors with the results from your data. You can send yourself emails directly from that Python code. So I hope that starts to give you an idea of what's in front of you and why Python is such a preferred language for transforming. Is because unlike SQL, like you're not going to be sending yourself emails through SQL scripting. It has its time and a place, but there's a lot more things that we do. Data dictionaries. So very important. These will help you understand your data sets that you're working with. It can get very confusing really quickly to try to do all this in your head. So typically the source, so this says spreadsheet here, but maybe the source is world.country or world. Let's say it's world. The table is country. And I would do a data dictionary for each table. I wouldn't combine them together. Then you've got your column name. Ignore destination table, destination column from now. What else I would add is like the data type. You could also put like I like to put a definition in natural language of what that is, especially if you're creating new columns. If you do any transformations, you can put those there. If you're using it like this, so if you're taking like your data lake or your OLTP data, your transactional data or something like that, and you're going to move it somewhere, you could do your destination table, your new column, whatever transformation you did. So the key things that you want to do here is just make sure you've know where it is. You're keeping your table name and your column names organized. You understand what the data type is. You understand how it works. Maybe you can identify your primary keys in there as well. It's really meant for you to, as you're managing, hundreds of tables or, even 5. It can get a little confusing. I would make a note in there. This, if there's a key, this connects to this table through this key type of thing. And any business rules as well. Right? Like we had the product amount, like products are only between $100 and $10,000, right? Can't have a charge without a transaction ID. All right, I know that was a lot. I'm happy to answer any questions. We're not going to have a ton of this on the final, but I thought it was important for you to know. So ETL, ELT, so extract, transform, and load versus extract, load, and transform. The big difference between the two is, if you're going to load something, a lot of folks load it into something they use an interface, like a user interface, to transform it later on. Not something that I typically recommend. I think it's easier just to extract something, put it into a data lake, which is, you are staging it, but you're just not doing any transformations until later. That's how I would think about it. So, data warehousing, OLAP versus OLTP. It's not always in a sequential order. It depends, one, what kind of data are you working with? Where are you getting it from? Where are you staging it at? But eventually all roads for what we do in analytics leads to OLAP. So that's how enterprises think about this. They think of job scheduling, right? Like if I know that the business day is done at 5 and I need to, update, let's say revenue for that night, and I'm going to do it automatically. I'm obviously not going to schedule jobs until after 5. If they're on the Pacific Coast, maybe I start on a Pacific time, Central, Eastern, that type of thing. I'm also going to automate like the different jobs that are running. So if I got a transformation program that I'm going to automate that, and then if it errors, I'll write something in Python to send me the error. Governing data, huge part of the job. Don't do it on your own. Buy somebody in finance candy, take somebody from ops out to lunch, and HR, get to know your friend, make a buddy with those different teams that's not going to mind you bothering them, that can help you manage the data. All of this stuff is business intelligence. It's a lot. But as you go through this program, through the Data Science Academy, you're going to continue to learn more and more about the different aspects of it. Nobody expects you to come out the gate understanding this stuff. It's something that you learn over years of experience. And then, as you go on in your career, what I would say is, let's say once you get up to manager, director, vice president, chief data officer, CIO, something like that, you're going to be focused more on strategies to, for data governance, storing it, very high level stuff. If it's maybe like a massive application, maybe you're worried about computational costs, storage costs, that sort of thing, and capturing the data that the company wants at a very high level, and then hiring teams, that sort of thing. If you're a data engineer, you're going to be focused on the ETL process and making sure that the data is extremely clean, that you've got awesome quality controls in place. Maybe you're going out to other teams to get different business rules, that sort of thing. And then if you're a BI developer, all that data is there for you. You're not really worried about the data lake. You're not worried about writing APIs typically to go pull data from somewhere else. You've got data, and you're going to create a new, maybe some new OLAP models, right, to produce some KPIs or to expand some reports and that sort of thing. And if you're a data scientist for Hy-Vee, you're really lucky. You don't have to worry about any of this stuff. They literally just give you the data that you need, and you can just spend your time running machine learning models all day. So like I said, there's all kinds of different flavors of this stuff, depending on what organization you're at. So additional resources for ETL using Python. It's very common. Data scientists and data engineers know it. Data scientists don't know a lot of SQL. They'll know a bit more in Python. They're typically expected to get handed the data first. Data engineers are going to be pretty strong in both. You can typically throw a language that they haven't even worked with, and they'll be comfortable with it pretty quickly. Python works in libraries, and you got to import the libraries as you use them. Pandas is a very common one that's used. There's different libraries for different APIs, which is why a lot of people like it. Like if you got to connect to Salesforce, there's all kinds of Salesforce APIs out there. It's extremely flexible and also robust. For example, like if I wanted to create a API and I wanted to go connect to Vonage, which is a common phone system, I'm going to do that in Python. I'm not even going to mess around with trying to do things in SQL. And then I'll stage the data in Python and load it directly into a data table in our servers. And then once it's there, then I'll use SQL to pull the data and do an OLAP database from transactional OLTP. So example, you've got a Salesforce API. It's coming down here. We're going to pull it into Python. Then we're going to load it into SQL. And then from there, we're going to load it. We've got to create an OLAP model. We will. Something like Vonage has probably got too many transactions we want to look at, too many fields. And then we're going to throw it into Tableau or Power BI, or maybe we start running reports and, sending Excel, files out. And then it goes to our audience. Okay, so that is our last lecture, class 7. And what I'm going to do right now is I am going to see if I can restart the room. And so Ali and Marcus can get in here before I talk about the final. All right, so look out for a new link.